Hello. Welcome again to the flipped classroom. We are studying inverse functions today, which is a blast from your past. So hopefully you will recognize everything I said. Looking at inverse functions undo one another. So let's look at a simplest case. Is where we have 3 points. Do these points form a function? They do if they pass the vertical line test, which guarantees that no two values of x have more than one value for y. And so any other line that I put in at any spot will never cross these 3 points more than one spot. So it is a function, and I was wondering, as I'm sure you are as well, what is the inverse? So the inverse is where we take the x values and the y values and we exchange them. So we have 3, 2 becomes 2, 3, 4, 1 becomes 1, 4, and 1, 5 becomes 5, 1. So those are the inverse of the original. So that's the simplest case. Let's look at something we're more used to looking at, such as, let's say we have f of x equals the square root of x. And I was wondering what function would undo what this function did to the x? Well, this function square rooted it, so you're probably saying the function that would undo that would be the squaring function. And you're right. To test it algebraically, which you will have to do, you will compose the two. So we're going to compose f compose g of x. I'll write it this way, and sometimes I'll write it the other way with the other notation. Would look like what? Well, we go to the inner chamber and we take g of x and first, and we put that as an input into the f function. So where we have an x in the f function, it takes on this whole expression. So do we not get square root of x squared, which is x? Notice in the innermost chamber we started with an x, and now this one function undid what the other function did, and we're back to x. If that's true, you've proved halfway that it's an inverse. The other half, we have to compose it the other way. G composed f of x. I'll write it this way. So that's the other way with the other notation. Can you handle it? And it looks like this. Well, this time we do this one first, and we get square root of x out, and that becomes the input into the g function. So where the g function has an x, I'm going to replace it with this whole expression. Do I not get the square root of x squared, which is x? So if you compose in one direction and then you switch it and compose in the other, you will find that the answers are x in both cases. That would prove algebraically that these are inverse functions of one another. So if I hand you 2 functions, do you know what to do with them? I think so. All right, we'll try one more. Let you try it. F of x equals 4x. So here's our next one. F of x is 4x. So what would undo that? I'm taking everything I put in this f function is multiplied by 4. What function would undo that? So the g function that will undo it, please write it, pause it, and write down what you think it is, or write it down quicker than I am, and compare. I'm saying that the g function will take what I put in it and divide it by 4. Let's test that algebraically to see if f and g are indeed inverse functions of one another. So first I'll do f compose g. When I do that, I take this value and put it in for that, and I get 4 times x over 4, which is x. And then I do it the other way. G composed f of x, and I'm going to do the f first, and that's going to go in for the x in the g function, and I get x as well. So they are inverses of one another. All right, I would like you to try this one. One more for fun, just for fun, of course. I didn't bring my tissues. I'm going to borrow some of yours. That's better than the erasers. All right. All right. The one I want you to try is g of x equals x minus 2 quantity divided by 5, and f of x equals 5 over x plus 2. All right, that looks like they're going to be inverses of one another, but we have to prove it. So go ahead and compose g composed f, and then f composed g, and let's see what shakes out. So this is a pause point while you do it. Come right back when you're ready. All right, here I am. I'm going to do g composed f. It doesn't matter which one you do first. Did you do this one first? You have great minds, like great minds think alike, so maybe, maybe not. I am taking this function and I am doing the f function first, and that is coming in to the g function right there. So there I've started, I hit my minus sign and divide by 5. So I have to simplify that to see if it comes out to what? X. Alright, so let's go ahead and do that. Upstairs here in the new, we can drop the parentheses and we get the 2 minus 2, and that leaves us with a 5 over x divided by 5. I'll put over 1. So when I flip and multiply, I get 5 over x times 1 over 5, and I get 1 over x. Ah, did you get there before I? This is not x, it is a 1 over x. So this failed the test, so these are not inverses of one another. All right, did you have fun doing that? I was wondering, and I'm sure you were as well, what do the graphs of inverse functions look like compared to one another? And it looks like this. Let's take this graph and recall we had y equals 4x is a sharp sloping line, supposed to go through the origin there, I'm off a little, and then y equals 1/4 x. Remember we saw those earlier that they were inverses? So here's the graph. Notice the pink one and the green one. All right, these are actually a reflection across some line. Can you see what it is? All right, keep that one on hold, and we'll go ahead and I'll sketch another one. Say I take this one. That's showing up? I believe it is. All right, so say this function goes like this. So I happen to know its inverse function, and it'll go like this. All right, can you tell from 2 examples what line these inverses are reflecting across? It is the line. I need another color to reveal the line, and the line is the line that goes straight through the third and first quadrants, which is the line y equals x. So we actually saw when we studied logarithms that the exponential and its cousin log were reflections across the y equals x line because they are inverses of one another as well. So, and here, in this one, the line should have been the straight line, but my graph was off a little. Hopefully you get the idea. So if I was to fold the board along this line, this green line would match against this pink line. It's a reflection across that line. If this was drawn well, and I could fold the board along this line, the purple would make an imprint on the orange. And that's how you can find quickly, with a quick draw, the inverse functions graph. All right, I'm going to shut this portion down and do one more segment. So, see you in a minute.